Okay, now some of the world's most important scientific facilities, from the Hadron Collider to the National Radio Astronomy Observatory, deal with massive amounts of data every day. Managing all of that is a huge task. It requires help from some really smart people. So the National Science Foundation is turning to expert computer scientists, including some from the University of Utah School of Computing and 5 other top universities, to help these facilities and other projects manage their data in a faster, more affordable way. And the team is going to be helping as many as 25 of the National Science Foundation's major research projects. That includes the Ice Cube Neutrino Observatory in the South Pole, the National Superconducting Cyclotron Laboratory in Michigan. This is cool stuff. I have no idea what it means, but it's really great. The Ocean Observatories Initiative and the Laser Interferometer Gravitational Wave Observatory at Caltech. Wow. I want to know what all those things are. So the guy who can tell us a little bit about the project, at least, is Valerio Boscucci, and he is a professor in the School of Computing at the University of Utah. Professor, this sounds like an exciting project. First of all, the big question, do you get to go to the South Pole?
No, not yet.
Okay.
But I can hope.
That would be cold, yeah. This is a really big deal. I'm a data geek. I love going into different databases and things like that. But man, this sounds like an overwhelming project. What's your job going to be going into this?
So yeah, as part of the center that we have in Utah that deal with massive data. So we are kind of a good member of this team. We help people dealing with really massive data sets, and we help them kind of explore and visualize their data so they can transform kind of the raw numbers into something that scientists can understand in an intuitive way.
Yeah, and I guess that's, as I think about this, I think about, we as the public. Today, I'm doing a story that relates to the weather, and I'm on the National Weather Service databases and all these kinds of things, and it's amazing what you can get, what you can find. So these projects that we're talking about, like the Radio Observatory, constantly measuring things. And every minute or every second, there's a different data point there. How do you wrap your head around that? You're not just tinkering with Excel.
Yeah, no, that's where kind of this large-scale data analysis and visualization tools are essential. We really group the data in go from the large quantity to kind of small summaries and kind of visualize the trends for the users to understand, but still with the ability to go in and actually check the details, kind of as if you were on an Excel spreadsheet. So you need to be able to do both. And also a key challenge that really work with is that moving the data from this large facility to the computing center where the actual simulation and prediction happen is really a key aspect of this type of work.
And so it gets to that computer setting, and there you're mentioning something key, because these aren't just, pie in the sky theoretical things. These are programs that help us understand what may happen to the Earth, what may happen to us in any number of different ways. And so is that what you're talking about? Like basically like getting this stuff from the satellite to actually in a place where you can model whether hurricanes are going to come, that sort of thing?
Yeah, exactly. So the scientists basically have to collect all this data, kind of transfer into some of those high-performance computing facilities, and then, for example, run simulation compared to the real data and see if their predictions match the expectations. There is, for example, a large project called NEON as a national ecology network. It's like having a telescope pointed actually towards the Earth. It's kind of a massive set of sensors, imaging, and so on. And then people in ecology and climate kind of collect all this data and see the effect, for example, of wildfires, the effect of changing climate, water availability, and so on, and how that change the ecological system in the various regions on Earth.
And, not to put too much pressure on you, but it does strike me that this is an extraordinary amount of responsibility, too. This data has to get in there correctly because the world is relying on that, right? I mean, there are people from all over who are going to look at what you have structured and to trust the information they base their science on.
Yeah, so with this CI Compass, kind of we provide the computer science helping hand to people that are focused on ecology, astronomy, and so on, and make sure that all the data gets to them in a reliable way. They can build what we call the cyber infrastructure. They become simple tools. They can use it, but then realize that things happen effectively, like errors are very limited and under control. All those things that go from just raw data to actual science insight. That's kind of where we work on. And part is building the infrastructure, and part is kind of training the people that run those massive facilities. In a way, our goal is to provide the training and the technology, and then make them independent on our direct support.
I'll tell you, I just find it fascinating, and I'm so grateful that you're spending some time with us. This is stuff that is so important, and I don't get a chance to talk with the folks who actually make this kind of data available. It transforms the world and how we understand it. So thank you so much for taking some time. Good luck. Sounds like a fun project and a mind-bending one.
Yeah, it's really fun. Thank you.
Fantastic. Thank you. And it's Valerio Pascucci, Professor of Computing Science at the University of Utah.
Thanks a lot.